Now from circle of thermodynamics, which relates dE, change in internal energy, with the heat and the work done by the relation D is equal to dQ minus W, and the value of work done W is equal to P into delta V. Now here the volume, that is delta V, is constant because this process is isochoric process. So at a constant volume, delta V is equal to 0. So this is isochoric process. So for the isochoric process, delta V is equal to 0. So now the equation becomes dE is equal to dQ. And we know that heat capacity at a constant volume, CV, is equal to dE by dt. This is the relation. Therefore, the value of D is equal to, that is change in the internal energy, is equal to CV, heat capacity at a constant volume, into dt. Okay, so now plug this equation in this. So we know that dQ is equal to, now the relation is dQ, that is change in the heat, which is equal to CV into dt. For n number of moles, this equation becomes dQ is equal to n into CV into dt. So where dt is the change in temperature and n is the number of moles, CV is the heat capacity at a constant volume. So in this problem, the value of Q, that is change in the heat, is given as 1 kilojoule, which is equal to 1000 joules. So in this problem, the dQ is equal to 1 kilojoule, which is equal to 1000 joules. So we know the value of dQ. Now the value of n is equal to 2. Number of moles is also given, so which is equal to 2, right? Now the value of CV, assume that it is a monoatomic gas, so it is about 3 by 2 into R, and we know the value of R. The value of R is equal to 8.314 joules per Kelvin per mole. Joules per Kelvin per mole. So this is the value of R. So now we know everything. The value of dt is the change in the temperature. The value of dt is equal to final temperature minus initial temperature. The thing is, the initial temperature is given, that is the value of T1 is given. The T1 is given as 298 degree Kelvin. Now they are asking for the T2, change in the temperature, the final temperature. The last temperature is asked. So we have to find out the value of T2. And the thing is, CV is equal to 3 by 2 into R. So now substituting all these value in this equation, that is dQ is equal to n into CV into dt. Okay, now if you are substituting all these values, it is found that, because we know that T1 and you are asked to find the value of T2, so plugging all these values into this equation, it is known that the value of T2 is about 338 degree Kelvin. 338 degree Kelvin. So this is the answer for the problem.